As discussed in the previous video, direct variation states that an increase in x causes an increase in y, and a decrease in x causes a decrease in y. An example is when a car's time of travel increases, the distance it travels also increases. Same as when a car's time of travel decreases, the distance it travels also decreases. Let us have some more examples. A local government organization launches a recycling campaign of waste materials to schools in order to raise students' awareness of environmental protection and the effects of climate change. Every kilogram of waste materials earns points that can be exchanged for school supplies and grocery items. Paper, which is the number one waste collected, earns 5 points for every kilo. Let us suppose this table represents the number of kilograms of paper collected and its corresponding points. Given this table, what happens to the number of points when the number of kilograms of paper is doubled? What happens to the number of points when the number of kilograms of paper is tripled? When the number of kilograms of paper is doubled, the number of points also doubles. And when the number of kilograms of paper is tripled, the number of points also triples. How many kilograms of paper will the students have to gather in order to raise 500 points? As we can observe in the table, a kilogram of paper is equivalent to 5 points. 2 kilograms equals 10 points. 3 kilograms of papers is equivalent to 15 points, and so on. This gives us a variation of 5 for every kilogram added. With this, we can form the equation y equals kx, where y is the number of points to raise, x is the number of kilograms of paper to gather, and k is the constant of variation. Substituting the values, this gives us an equation 500 equals 5 times the number of kilograms. Solving for the equation, we have to divide both sides by 5. Cancel this out, and then divide 500 by 5, which equals to 100. And 100 is the number of kilograms of papers that the students have to gather in order to raise 500 points. Using his bicycle, Jericho travels a distance of 10 kilometers per hour on a steep road. The table shows the distance he has traveled at a particular length of time. What happens to the distance as the length of time increases? As we can observe in the given table, Jericho can travel 10 kilometers in 1 hour, 20 kilometers in 2 hours, 30 kilometers in 3 hours, and so on. We may say that as the length of time increases, the distance also increases. Using this pattern, how many kilometers would he have traveled in 8.5 hours? The given table gives a variation of 10 kilometers for every additional hour traveled. This gives us an equation y equals kx, where y is the number of kilometers Jericho would have traveled, k is the constant of variation, and x is the length of time traveled. Substituting the given values, this will further give us an equation y equals 10 times 8.5, or in decimals, 8.5 is equal to 8.5. To solve the equation, we have to multiply 10 by 8.5, and that gives us a final answer, 85. And 85 is the number of kilometers Jericho would have traveled in 8.5 hours. The previous activities leads us to a conclusion that there is direct variation whenever a situation produces pairs of numbers in which their ratio is constant. Let us have a look in this table of values. If you gather 1 kilogram of papers, you will have 5 points, which is equal to the ratio 1/5. If you gather 2 kilograms of papers, you will have 10 points, which is equal to the ratio 2/10, or in lowest terms equals 1/5. If you collected 3 kilograms of papers, you will gather 15 points, which is equal to the ratio 3/15, or in lowest terms equals 1/5. If you collected 4 kilograms of papers, you will gather 20 points, which has a ratio of 4/20, or in lowest terms is equal to 1/5. If you gather 5 kilograms of papers, you will have 25 points, which has a ratio 5/25, and in lowest terms also equals 1/5. If you gather 6 kilograms of papers, you will have 30 points, which has a ratio 6/30, and in lowest terms also equals 1/5. The ratio of the pairs of numbers in this table of values is constant because the ratio are all equal to 1/5. Now look at this second table of values. If you traveled for 1 hour, you will travel a distance of 10 kilometers, which has a ratio of 1/10. If you travel for 2 hours, you will travel a distance of 20 kilometers, which has a ratio of 2/20, or in lowest terms is equal to 1/10. If you travel for 3 hours, you will travel a distance of 30 kilometers, which has a ratio 3/30. In lowest terms, also equals to 1/10. If you travel for 4 hours, you will travel a distance of 40 kilometers, which has a ratio of 4/40. In lowest terms will be 1/10. If you travel for 5 hours, you will travel a distance of 50 kilometers, which has a ratio of 5/50, and in lowest terms is equal to 1/10. The ratio of the pairs of numbers in this table of values are also constant because the ratios are all equal to 1/10. The statements y varies directly as x, y is directly proportional to x, and y is proportional to x may be translated mathematically as y equals kx, where k is the constant of variation. In direct variation, we can further conclude that for two quantities x and y, an increase in x causes an increase in y, and a decrease in x causes a decrease in y. If y varies directly as x, and y is 24 when x is 6, find the variation constant and the equation of variation. First, we have to express the statement y varies directly as x as y equals kx. To solve for k, we have to substitute the given values. Y is said to be 24 when x is 6. So let us substitute 24 to variable y and 6 to variable x, and then solve for the value of k in the given equation. To solve for the value of k, we have to divide both sides of the equation by 6. Cancel this out. And k is equal to the quotient of 24 and 6, and that is equal to 4. Therefore, the constant of variation is equal to 4. Now, to obtain the equation of variation, we simply have to substitute the value of k, or the value of the variation constant, to our original equation y equals kx. Y equals kx will be substituted by the value of the constant of variation, which is 4. So our equation of variation will be equal to 4x. The table below shows that the distance d varies directly as the time t. Find the constant of variation and the equation which describes the relation. So first, we have to express the statement, the distance d varies directly as the time t. Mathematically, that will be translated to the mathematical equation d equals kt. Using this equation, we also have to use a pair of values from the table of values. We can use the smallest pair of numbers. So the value of d that we have to substitute is 10, and the value of t that we have to substitute in our equation d equals kt is 1. Okay, d is equal to 10 and k will be retained, t will be equal to 1, and then solve for k. We have to divide both sides of the equation by 1, cancel this out, so the value of k is equal to 10. We may also use other pairs of numbers from our table of values. Let us try using the largest pair, which is 5 and 50. So the value of the distance will be 50 and the value of time is 5. We will use the same equation, d equals kt. So d will become 50 and p will be 5. And then solve for k. We have to divide both sides of the equation by 5. Cancel this out, and the value of k is the quotient of 50 and 5, and that is also 10. Okay, now that we know that our constant of variation is equal to 10, we may now proceed to finding the equation of variation. And we have to substitute the value of the constant of variation to our expression d equals kt. So the value of k is 10. And the equation of variation will then be equal to d equals 10t. If x varies directly as y, and x is 35 when y is 7, what is the value of y when x is 25? First, we have to translate the expression, the statement x varies directly as y, to the mathematical equation x equals ky. And then we have to use the given values. X is 35 when y is 7, to solve for the value of the constant of variation, which is the variable k. Substitute 35 to the value of x, retain variable k, and substitute 7 to variable y, and then solve for the equation. Divide both sides of the equation by 7, cancel this out, and k will be equal to 5, which is the quotient of 35 and 7. Now that we have the value of our constant of variation, we may now use this to solve for the value of y when x is 25. Again, we have to use the mathematical equation x equals ky, but by this time, we have to use the value of x, that is 25, and the value of k, which is 5, and then solve for the value of y when x is 25. To do this, we have to divide both sides of the equation by 5, cancel this out, and the value of y is the quotient of 25 and 5, which is equal to 5. Therefore, the value of y when x is 25 is equal to 5.